Alrighty, I think it's time for another update from the design team. So here over at Nick and Time Design, I'd like to show off one of the projects that I've been working on for the past like 2 or 3, probably three months now, which is the Trinity fan controller. So if you guys seen one of my older videos, I made just an alpha model for myself of just a little basic fan controller with a couple buttons and some business on the back, and it turns your fans on and off. You can set customized temperatures and get the engine to be exactly where you want it to be with full control. So after lots and lots and lots of designing and looking and working and trying to figure out how to do all this stuff myself, we finally have a prototype. Schematics and all kinds of stuff. Okay, so in case you got something against Facebook and you don't feel like clicking, I made a big post about this guy. So this is the full feature list that we have for the TFCs, the Trinity fan controller. So we got a 4-digit alphanumeric screen like you saw. We got 3 buttons for selecting inputs, RGB LED that shows off what fan mode you're in. We got a light sensor for auto dimming, 3 separate fan channels with PWM possible. We got a manual override switch for fan 1. We got an AC signal input, so it'll come on with the air conditioner. We got a temperature sensor input with included probe, or you can add a custom one if we can figure out the math together. And it's got an engine bay wiring block that mounts separately. So those are the main features, and then we would get into the more complicated stuff. We got a switching voltage regulator for better efficiency. We've got fuses on everything for 500 milliamps, but I need to do more testing to figure out if they work properly. We got a dual diode snubber for relay coil noise suppression, which doesn't really matter much. It's really just to protect my product. Micro USB point for updating. Got 2 free analog digital pins broken out for custom stuff, and we've got 5-volt ground and E1 breakout pins. And then inside the box you got the Trinity fan controller, the engine bay wiring block, 3-foot of temperature probe, which I might include more when I order from a different source. And we got 10-foot of Ethernet cord to run it inside the vehicle. So yeah, that's an overview of what those crazy little fan controllers can do. So this design is really exciting because it's the first one I've ever made that has a microchip actually embedded on it. So there's no more development boards or any crap like that. Because before, I'd use systems like this. You buy yourself a pre-made board and plop it somewhere on there and figure out how to mount it and, solder all these darn pins, and it takes forever. That's part of the reason why I'm not making REMs right now, is just because, when you're soldering like 80 pins a piece on there, it takes too long. It's terrible. So, this is really cool. So this uses an Atmel, a 32U4, which has the USB built in. So we don't need a separate USB chip, but everything you see right here, I built myself. Completely. Designed it, figured out the board. All we get is a bunch of blank boards, just like this. And I actually put all those little itty-bitty components on myself, which is awesome. So, first, check it out. I cleaned up the workstation over here a little bit. We got ourselves a nice shelf. Got a hot air rework station now. Dude, this thing is freaking awesome. So it actually uses a hot air nozzle to solder things. It just blows hot air, and it gets hot enough to actually solder with. It's really, really cool. That is a cool little system. I got that on sale for like $200, and it's great. So yeah, we got that thing now. We still got the fancy soldering iron. Got our 12-volt power supply. We still got the ducting for the 3D printer. So yeah, we're getting a nice little workstation now. It's looking pretty legit. You can see the case design right here. This is about the 4th redesign that I've gone through, and it's actually looking fairly decent now. The only hard part is the switch, just because of how the unit gets assembled. Bit of a pain in the butt, but otherwise not bad. It's starting to look like something. Over here is the engine bay adapter that you can plug all your wires into. So you got like your ignition, your ground, your fans over here, your AC, your temperature probe, and all that. But anyway, let's turn this thing on and see what it looks like, huh? Show you my absolute favorite part. This right here. The Trinity fan controller, and you nerds out there might know why I called it that, but I absolutely love the name. So, this thing is able to control 3 separate fans. We got a temperature switch that you can put in the radiator or whatever, and I also left a port so that you can use a different temperature sender if you'd like. I'm going to use the thermostat houser probably, but this thing's got all the bells and whistles, my friend. So, we've got a menu button down here, and then we've got one to change over here, so we can change what's going on, their temperature. All the different fan on and off points are controllable. So you have your low on and off, your medium, your high, and then you can also change the pins. So for the low, you choose what fan you want. So we got fan 1. You can also have fan 2 and fan 3 if you wanted. You can move over to the medium fans, the high fans, and even what happens when the AC comes on. So that is what I got coded right now. I've been working on this thing for an entire week straight. These designs just came in Monday, and it is now Saturday. And I went from a blank board to a working prototype in less than a week. I've been so excited to check this stuff out. So yeah, that right there is the Trinity fan controller. Yeah, like I said, if you're looking to have a completely customizable fan controller that can, turn 3 fans on and off with AC input, temperature input, and any other kind of thing you can think, we have one free pin in here, E1, which we can use for stuff. So we got our E1 pin that comes out over there, and we've got 2 analog pins, A3 and A4, so we can do stuff with that. So that'd be cool. With the AC input, it's usually going to be a 12 volt input, so you give it 12 volts when you're getting AC. But there's also a resistor on here if you want to set it to a ground input. I still have to mess with that to see how well it works. Again, I haven't really had the time to test it yet. I've been working my butt off just to get a something that looks like a product. So I still need to do more testing. But yeah, things are looking pretty good so far. So the way that this system works, it is a low side controller. So this doesn't take the full amperage of the fan. All this does is turn your relays on and off. So that way we can keep components small and stuff cheap. So here we have a relay. We would hook the fan up to this, and the relay would take the actual fan load. This just turns that on and off. So I got to see what's going on. I accidentally plugged in a relay that was shorted, and I blew one of the pins up on the transistor. So I need to figure out why the fuses that I put in there aren't working the way I thought they would. But here's a perfect example of why I added this switch. So this switch completely bypasses everything in this system. It is fully manual. All this does, this switch brings the fan 1 pin directly to ground. So even if everything blows up, as long as you have a wired connection, it'll still work. So we flip our switch, and our relay works. So let me hook this onto fan 3 so you can see what it looks like when this guy uses it. Okay, so now we are hooked up to fan 3. So if we come into our manual mode, switch this to high. Sweet. So that does work the way it's supposed to, as long as the thing isn't shorted. Also added a little section here where if you hold down home, it takes you home. It's really cool. I'll probably add a menu timeout. There's still a lot of coding left to do on this, but the base product is done. I could plug this in and use that right now. Yeah, so that's the basic setup. So if you guys are interested in being a prototype tester, these kits will be $75, and that's just to cover the component cost, because when you're doing small batches, stuff's expensive. There's a couple different color screens that we can select, so you can have all kinds of things. There's more than just green. But they aren't RGB, because that's ridiculously complicated and expensive to try to do that for 7-segment. Since this is an alphanumeric, I don't know if you noticed that, but we can actually display like letters. In the alpha version that I had, it only did numbers, so it was really hard to do like W's and things like that, because it just looked terrible. So this one, it looks really cool with that alphanumeric display. So here we have a few colors. These are all from Adafruit. So we've got a blue, we've got a yellow-green, we've got a full green, we've got red, white, and I don't know if that's orange or yellow. It looks a little orangey. But yeah, you got a selection of any of those 6 colors, and we can do that. So the whole kit, you get yourself, you know, one Trinity fan controller, an Ethernet cord, and you get this little engine bay adapter and a temperature probe. So everything you need to get it all set up. Now over here on the engine bay side, I've been trying to figure out how to get a good design. These are all push button, so you just push these little things down in order to use them. So it kind of rolls forward a bit, and then the contact opens up. I figured that might be an easier design than the screws, but I designed this to use both. So if you guys would rather have a screw instead of just the push button, let me know. I don't know how well these are going to work. Again, these haven't been tested yet, so I don't know if they're ever going to wear out or how well they'll hold, but they certainly hold big wires. I made sure to select ones that can hold big wire gauge, so that shouldn't be an issue. You can see there's 2 little diode arrays in there. This is a fancy thing going on here. So for those of you that don't know, apparently when you open and close, or when you open a relay, you know, when you're shutting it off, it creates a lot of noise, because the coil inside the relay is basically an inductor. So what that means is there's a lot of magnetic energy stored inside of it. So when you turn it off, all that energy, when that field collapses, it's got to go somewhere. So the voltage goes through the roof as it tries to find a path to go. So what these diodes do is it provides a reverse path for that energy to go through the coil and you know, slowly wear itself out, instead of spiking and like breaking, you know, transistors and things like that. For sensitive electronics, they don't like big power spikes. But that creates a second issue. So when you put the diode on there, what happens is, okay, great, now your spike is completely gone, but it takes longer for the relay to open. We're only talking a couple milliseconds, but for really high-powered loads, that might be enough for the relay to not fully open. It might like open and close a couple times. Sometimes that can cause micro welds and things like that in rare cases. So I didn't know about that. So after doing some reading, I added another diode. So now we have a regular diode and a Schottky diode. So the Schottky waits, you know, it holds back until the breakdown voltage, which I think is like 40 volts or something. So after 40 volts, then the voltage can pass through the regular diode and burn itself out. So that way we keep our voltage spike kind of low, but we still let the relay open quickly, because the spring needs to overcome that magnetic force. So hopefully that fixes everything. I didn't realize coil suppression was so complicated, but yeah, we got little itty-bitty diodes in there that should keep all of our components nice and happy. So there's something you know now. Okay, so let's talk about how the heck I actually put these things together. So we obviously start with a bare blank board like this, and it would be absolute hell trying to solder these things together, you know, by hand. I went with 0603 components, which are, you know, tiny. They look like dust. If you want to see what the parts looks like, this is what they look like. So these are resistors. I can't even like show you. Or these are actually capacitors, but they look exactly the same. So we can get these to focus. Look at those itty bitty little guys, huh? Each one of those little things is a capacitor. And I gotta solder them by hand. This is a hand, by the way. That's a finger, but you know. Yeah. So we got lots and lots of itty bitty tiny little teeny weeny lemon squeezy components. And the heck are, and in case you guys are curious, this is what the screw style look like. They're actually at a right angle, so they stick up a little bit. But they got little Phillips head screws on there, so if you wanted a screw style approach, we have those too. I only ordered a couple because I wasn't sure if I'd like them or use them, but yeah, that's an idea for you. But anyway, in order to put these together, I ordered something called SMD stencils. So what this is, you know, all the components that need solder paste get cut out onto this little metal sheet. So I got a little indexing thing here. So we take our thing and we put it in here. It certainly is a tight fit, Jesus, come on. There we go. So we slide that in like that. And now, if you notice, our stencil lines up with all the pads. So then we take something called solder paste, which is, it's literally just like a paste, and we smear it on here. And then when you take the board out, all the paste is on there. So what it does, it's a little sticky so that it actually holds all the components. So you place all the components down one at a time. You know, these itty bitty little bastards, and you heat them up with the heat gun over there, and it does wonders, man. It melts it, and it literally sinks itself right into place. It's really, really cool. So yeah, that thing is totally worth the money spent in order to build these prototypes. Because I could get these manufactured by, you know, the PCB place, but it's expensive. So to try to keep costs down, I figure I might as well do this stuff myself. Okay, so I think that's just about everything on these guys, but I'm so excited. Did I mention these are auto-dimming? Because they're auto-dimming. Let me see if I can... Yeah, I don't know if you saw that, but it dimmed. That's cool. So yeah, we got auto dimming and, you know, just everything. This is designed to be like one of the most customizable fan controllers out there. I've tried to look and I don't really see too much out there. Another thing, these things have since they're transistors, they have PWM output. So I still need to do a lot of testing here, but the idea is if you get yourself a solid state relay, which is basically like a gigantic transistor, which could actually power the fan, you can use PWM, or pulse width modulation, to turn it on and off really fast to actually control the fan speed. So you can have a variable fan control to have it like exact. Now that is some really cool stuff there. But solid state relays that can power fans are expensive. So yeah, if you guys have any leads on those, if you have any, you know, spots where I could find one that's, you know, decently cheap, I might try one just to see, you know, proof of concept. But that would be a really cool, you know, side thing for people that were interested in that. So if there's any features that you don't think I mentioned or something, things that you want to see in, you know, a crazy fan controller, let me know, because I'm trying to design these to do everything, you know, anything you'd ever want out of a fan controller. So yeah, there's that. And while we're nerding out here, let me just say that I am absolutely super proud of the code that I'm writing here for this alpha software. It is by far some of the cleanest code I have ever written. It is glorious. It's beautiful. So if we come down to like when things happen in the main loop, everything's separated into what they do. So we got like, here's the temperature sender, here's the dimming stuff, here's the button stuff, and everything has their own little thing. So we got like, each one has its own averaging function, and then we got a debounce function with flags and stuff like that. And we come down here and we can, you know, set everything. Each menu has its own little buffer. So instead of doing everything manually, you just put in the text that you want, and it's really, really, really clean. I'm super proud of how simplified this code is. This one still needs to be cleaned up. We can make that a function too. But like, this is everything right here for like the fans and stuff. So, you know, we have our flag that tells you, okay, this is what you do for none, this is what you do for AC, for low, and we have our fans set in our color, and then it just writes it once instead of having everything laid out. All the magic happens behind the scenes on this function tab over here. So like when you ask it to get the temperature, it does a lot of stuff, you know, like we read in the temperature a few times to average it and do all this stuff to try to figure out this sender. I added my own polynomial correction factor in here to get a more accurate reading from the approximation formula, converted to Fahrenheit. We got all these buffers and printing and decimal points and custom stuff, averaging arrays with pointers. Oh my god, I just learned how to use pointers to go to different addresses and stuff. That's super useful for doing functions and having them like modify things outside of the scope of the function. That's super useful. You'd think that a global variable would be global, but apparently not. But it's just, oh my god, it's so clean. Got our little dimming formula in here, so we're not even doing like multiple. It's just, oh my, I can't even, you'd have to know code to appreciate this. Which brings me to the next topic. I've learned a lot about Arduino and coding and building and stuff like that. So would any of you guys be interested in Arduino coding tutorials to show you the basics? We're talking start all the way from you know nothing to get you to the point where you could make a little project if you wanted. So this would be, you know, I could probably make anywhere from like 5 to 10 different like tutorial videos going over different things. So if you guys are interested in learning how to do coding, you know, even if you're just curious how the thing works or what an Arduino is or stuff like that, you know, I'll even go through the basic stuff, because this is what the fan controller looked like before. This was the prototype. figuring everything out. So we got our voltage regulator over there, and you know, the main chip, and you hook everything up and breadboard it. But I could show you how to start all the way from the beginning with, you know, like a pre-made board like this, or wherever my Uno is, this guy, the Uno, and you know, work your way up to make a project. So if you guys are interested in learning how to code, let me know. I'd probably make the videos regardless, just because I couldn't find the tutorial videos that I wanted to when I first started out, so I just had to do all the reading myself. But yeah, I feel like I could do a really good job and, you know, kind of make it interesting. So yeah, let me know if you're interested in that. I'm getting sidetracked because it's hard to remember everything, but I'm actually using a pogo pin system for programming. So these little spring-loaded pins, I'm using this guy as a programmer to program these guys, because our raw chips, this is the chip right here, it doesn't come, well, it comes with the Atmel bootloader, but I have no idea how to use that. So I've got breakout pins on here, the little ISP right there, that little 6-pin up there, to program it. So we can just take this guy and just press it onto the board and program the bootloader in there, and then upload the rest through USB. So that's really cool. These are going to be user updatable. So if you guys are interested, just make sure to know that these are prototypes. This is basically a brand new untested design. I have no idea what works, what doesn't work, what could possibly go wrong. So just be aware that if you guys are interested in trying these, you know, I'm not sure what could go wrong, but you know, stuff is always bound to go wrong. So just remember, this isn't a finished product. If you're looking for like a no hassle thing, you might want to wait a little bit until the next batch. This is for prototypes. So just remember, you know, I need feedback. Okay, I need to know what you think, what you like, what you don't like, because, you know, I'm always trying to make these better. So yeah, just keep in mind that your feedback is extremely useful if you'd like to be a prototype tester. Okay, so one other big thing that I'm really excited to see how well it works on this design is the switching regulator. So over here, this little tiny itty-bitty square guy, that is our new voltage regulator. And the interesting thing about that is that it's a switching voltage regulator, which is way different than the linear ones, the old style. So on our old designs, you know, I've had people put on these gigantic linear guys, and the way that they work is the Arduinos only work on 5 volts. So when you put 12 volts in, that would blow them up. So you have to bring the 12 volt down to 5 with a voltage regulator. The linear style, all it does is burn all the extra energy off. So these things get really hot, like up to like 250 degrees. And that's just what they do. They just burn off all the extra heat. Well, this little guy is supposed to be able to handle 1.5 amps, and that barely works. Dude, these boards only take 100 milliamps. This thing is supposedly rated 10 times what it needs to be. And yet, I still hear occasional issues from some people. It's ridiculous. I hate them. This is such a terribly inefficient design, but they're easy to install. All you do, you just got 3 pins, and that's it. You're done. You don't even have to do anything else. So a smarter approach is a switching design. So what this does is it takes in the 12 volts and it chops it up into little itty-bitty bits. It's basically pulse width modulating. And then you take yourself some capacitors and an inductor, and that smooths out the signal so you can get a nice clean signal. So now it's taking 12 volts, chopping it up into 5, and averaging it so that this has power, and it uses almost no energy. This thing makes almost no heat. It is incredible how little power that uses. It's super efficient, and it can take a ton of current, way more than the other design. So that little guy should be enough to power the REMs, but I just want to see how these do out in the wild and see what people you know, think, if they report any problems. I'm very confident in this design. So that was a big issue with the REMs, is that they just overheat and don't work with those old style linears. So yeah, I'm super excited to test that out. So yeah, that's the Trinity fan controller in a nutshell. Again, I'm absolutely in love with that name. Just brings warmth to my heart. The coding and the tutorials, I went over that. So I guess now we'll talk about the REMs in general. So if you don't follow the Facebook page or anything like that, I've been out of stock for a couple months now with the V4.1s. So, you know, we've had, you know, the clock style over here that sits inside the panel. Because a couple people were confused about what everything meant. So this is the clock style. It fits inside this little guy, and it sits in the dash. It is a complete panel replacement design that, you know, it looks pretty factory. But, you know, with this added clock, this stupid clock on here has caused me so many issues. This display with this little itty-bitty chip over here to control it, I can't even go over the amount of headache that this design has brought me, man. I've thought about scrapping this entire thing several times. It's driven me nuts. How terribly just... I2C, man. It'll drive you nuts if you get a chip that doesn't work right. So, the reason why I'm not selling them right now is because they need way too much work. So, the first thing that we're going to do is we're going to take this chip and put it onto the board. So, with the Teensy design, these are a lot more complicated than Arduino, so I need to do a lot of looking into what it takes to get this chip to work with all the different passive components and the, you know, everything. So, yeah, we need to do a couple prototype boards to get that on there. That'll make it a lot easier to build. Because right now those pins, all those pins I have to install, that takes way too long. I can't build these fast enough for you guys, and especially make the cost good. So, yeah, we're going to embed this guy. We're going to do a switching voltage regulator. I'm going to do a different chip for the clock, display, controller. I don't know if I'm going to use a higher, like a brand name I2C design, or if I'm going to switch to SPI, something that's a little more robust, maybe on a different circuit. The RTCs, a few guys have had issues with these guys. I mean, these guys are little China little businesses. This keeps track of your clock, your calendar, your time, all that stuff. It's just got a little battery, and it goes over I2C too. That's the communication. But yeah, if that line gets messed up, like the gyro runs off that, this runs off that, that runs off that, if any of these guys decide that they don't want to work, then everything else, you know, goes to hell. So we need to make sure that communication is good. The Teensies actually have a built-in RTC module. It just needs a separate crystal on those two little holes right there, and then a battery. So I might try doing that. It might not be as accurate. The reason why I picked these DS3231s is they're temperature compensated. So when they get colder and hotter, they vibrate a little differently. So over time, they start to lose track. This one is temperature compensated with a temperature, you know, sensor in there that offsets the crystal business to get like a super accurate time. So, you know, I love accuracy, I really do. But if they're causing issues and they lose track, then I'd rather go with something slightly less accurate if it means it'll be more reliable. So that'll be another thing we have to test, is that. We're going to make the passive components a little smaller. So these are 0805. We're going to go down to 0603 just so they fit better. And the in-out system needs a lot of work. A lot of people are really confused about how this system works, because you can run fans off this, you can run sensors on this, inputs, outputs, all kinds of stuff, but it's a little complicated to figure out. You know, because we got voltage dividers in here for inputs and stuff like that. There's lots of jumpers. The signal out's a little complicated, so we're going to try to work on that to make that a little easier for your guys. I'm going to see if I can just add dip switches or something, so you just flip one switch to go between an input or an output, so there's no soldering involved or anything like that, because a lot of people, that scares people away, and that's understandable. But yeah, I'm going to try to make the in-out adapters a little easier to use and just all that. So again, with the fan controller, this is going to be a good test for all that to see how well everything works, what's good, what's bad, stuff like that. And that'll make the REMs better. So this is really important for a couple reasons. For, you know, one, the new design, but two, there's a lot of new processes I'm using. So I want to see that everything works properly before I order big batches. So once these guys are out the door, once I sell these and I know that they're kind of working and I'm happy with that, then we can start work on the REMs. So hopefully in the next coming months I can work on the design, build them, test them, get them to work right, and start selling them again. The goal is to have these in stock, and that's going to be difficult because a lot of people like these. I'm super excited that you guys like these products as much as I do, because they're really cool. For the Renix guys, it's stupid helpful how much these REMs help for diagnosing and stuff like that. Oh man, you haven't even heard about the code, and there's so much to go over. But yeah, I want to make sure that these guys work properly. For the clocks, I'm not super happy with the 3D printing cases. These look kind of like crap, and when it's in the dash, it just doesn't look quite right. It's okay for most people, but dude, these things take 3.5 hours to print a piece, and a lot of them, I've been having a little strip on here. Just one of the little pieces of plastic doesn't lay just right, and it looks like crap. So you got to throw 3.5 hours away for one stupid little blemish. It's absurd. So what I'd like to do is get these injection molded. I was talking to a guy a couple months ago that said that he'd be able to help me out to actually get these cases injection molded so they look really clean and factory. So I'm really excited. Not only will that make this process a lot faster, because I won't be constantly throwing away plastic and burning away 3.5 hours to print these damn things, but they'll just look better, a lot less headache. So I'm really excited to see how that goes. So these should look really nice and professional. So yeah, a lot of hardware fixes on, you know, just about every account. I need to talk with the Bluetooth developer that makes the apps, Lucio. He, you know, these are the little Bluetooth guys right here, but they only work for Android. I've been doing some reading, and apparently with Bluetooth like 4.0 or something like that, I might be able to talk to Apple devices now. So I need to see. It looks like they're the same form factor, so hopefully I can just switch this out for like an AT09 or like an HM10 or something like that. I don't know. Again, I need to do looking, but hopefully he can help me out with that, since he's the one writing the app and actually controlling all that. So he's working on like a landscape mode and stuff for tablets and stuff like that. So yeah, the Bluetooth, hopefully we can get more compatibility for you guys and all that. I've done a lot of software. The Renduinix software has come really far, and it's ridiculous. So for you guys that don't follow Facebook or anything like that, all the original REMs, like the REM and the REM Plus, I released a software update that will be probably the last update I'm ever going to do for these old guys. I've done so many fixes and things like that to try to make the data more reliable, to make them more to make them faster, add more features, everything that I could possibly cram into there. I've done so much, but these are maxed out. I just it's time. You know, I'm happy to say after a year and a half that these are finally what I would consider a finished product with the software as well. But yeah, they're just, you know, the hardware is not great. So yeah, for you guys that haven't updated, if you were looking for an excuse to do so, now's the time, because yeah, they have 0.86 is probably going to be the last update they ever get. So on to the REM2 software. There's a lot going on here that I've been working. I recently got a wideband O2 sensor, which is cool as heck, but yeah, I'm using that as an input. So I'm reading in the sensor, showing a AFR value, and then spitting out a narrowband signal with the signal out thing. So that's really cool. So I'm actually controlling the ECU with a fake oxygen sensor signal based off wideband, so it's super accurate. I'm going to make a whole big old video on that, you know, when we get there. But let me just check to make sure this is the right version. Yeah, this is 0.87 is the latest one. So I don't even know where to start. Like, how far back do I go? In the diagnose menu, we've got a couple things now. So now, when you hit the menu button, we have min-max for everything like we had before, but hit it again, and we have software graphing. So there's actually a little line that'll go up here and show you what the data looks like, and it's really, really helpful. That was cool. That was really cool to make a custom characters that draw things. Let me see if I can put a clip in there for you. Alright, so this is, I'm only updating it once every 100 milliseconds, and it's also got a running average of 6 different points. So this is rather slow, but now if you notice, it actually kind of looks like the old signal, at least a little bit. It's not nearly so jagged and bumpy. But yeah, we got that. So now, what else do we got? So we have the ECU detected and our mystery bytes and stuff like that. Now we have trip history. So now I actually save how many miles and gallons we went on a trip. We also have a tank history that actually saves it to the memory, so it tries to keep track of it. You can see how many miles and how many gallons you have left. So if we go into like the vehicle, now we have option for the tank size. So we have our 20 gallon and our 13 gallon. And when we go into here to options, now we have the fill up menu. So now we have, you know, if you have a fill up, like a full fill up, you hit that. You can have a partial fill up, or you can have a missed fill up, and then you just, you know, change how many gallons you put in there. You can also hold that down if you need to, and you hit save, and you hit yes to save, and then it'll save how many gallons you have. Now, after the first fill up, it will do calculations to try to figure out if the injector, if it's guessing properly on how much fuel is used. So after the second fill up, you'll notice that this calibration number will change, and then your gallon per hour, your mile per gallon, stuff like that will be a lot more accurate, because it'll actually be what the system is. So I need to do some more code to figure out if everything's right, but I might be able to show the injector, like your actual injector flow rate, because each one will vary a little bit, and if you put different injectors in, then the math will be off and stuff like that. So that's really important to look into. So yeah, I found a new gauge. Oh my god, I'm super excited. So here's that AFR gauge I have for the wideband, but that's only if you have a wideband sensor. So let's go over that real quick. So when we go into our settings, in the advanced menu, we got our Bluetooth. We have Bluetooth speeds. I found that sometimes some phones can't process the speed, the information fast enough, and it starts to lag. So if you notice your app is lagging, like if you hit the throttle and it doesn't show up for a while, set this to slow, and then your app should be able to stay up to date. That's super important. Next up, we get the gyroscope. That's, we've had that. The calibrate function, so you can, calibrate it so that it reads 0 and all that. We have our USB output. We got a couple different things here. So the normal mode is it'll give you all the actual readings. So it'll tell you like this is your your map sensor and all that stuff, and everything's calculated. We also have raw. So what this does is it spits out just the raw, like the bytes, instead of anything calculated, which is useful if you're trying to pick things up. And this is actually how I found out that there's a gauge for the neutral safety switch. So I'll show you that in a sec. And then we have pass-through. So what this does is it reads the data in and it spits it out the exact same way, so you can use it for data logging other things like RenexCom on PCs. So you can use this as a serial port to pass that through and graph it on that. That's really useful if you need that. But for most people, normal should be fine if you even use it at all. We also have our wideband reading. So I've got two different profiles in here. These are the AEM profiles. We got 10 to 20, and we also got 8.5 to 18, which is mine. So that's cool if you ever wanted to do that. And we can also select what pin it's on. So there's that. Cool. Alright, so now let's check out that other stuff. The VHT reading on here, I redid the math to accurately calculate the diode drop with like a calibration number, and I'm super proud about that. So now this should be extremely accurate. Before it was a little hazy, especially in the lower numbers, but now that should be spot on. So over here is our neutral safety switch. So this will switch between park neutral and the drive gears. So this is cool. So if this reads drive and you can't figure out why your vehicle won't start, it's probably because your vehicle isn't in park. So that's a useful thing to see if this works, because this is an ECU value, which is different from the AW4 one. This guy over here, when you're into like, if you're in like park or third or first, second or stuff like that, this is from the transmission, and this one's from the computer, the engine computer. So that's really cool, and I found that out from Bits. So this is why I like to keep things open source. So there was a smarty pants that figured out that inside the binary stuff is each one does something. So like for instance, let me show you in the custom menu here. So right here, if you notice, this looks a little complicated, but this is how we make symbols for the 7 segment, but this is actually 14. So this is actually 16 different things. So you think, okay, you just go through the numbers and try to figure out which ones do what, but that's the dumb way to do it. The smart way is to realize that each, every single bit, each byte has 8 little digits in here, an on or an off. And if you figure, hey, that could correlate to the fact that things like every single one of these could be on or off. So that's what it is. It's stored in the bits. So you find out which bit it is, see which one's switching, and then you can do that. So when we go over to this guy, and we go into our get data, and we scroll down to where are we at? So much crap. NSS. Okay, so we can bit read. So in here, I found out from someone else about the bit reading, and found out that in the AC the AC one right here, the Stream 29, the 7th bit over here is actually for the NSS, so you can actually see it switch back and forth. And when I saw that and the guy figured it out, I'm like, wow, that is awesome. So let me look him up so I can give him credit, because he really helped me figure that out. Because before I was trying to figure out the complicated math where you divide by a number and figure out if it's like true or false. Like this stuff over here, you divide by 64 and then do some modulo to figure out if it's true or false. And it's just, oh, that's such a dumb way to do it. I'm really glad he figured that out, because it didn't click for me. Okay, so for those of you that forgot, I have a Facebook page, Nick of Time Films, and I go through everything when I'm doing updates for the Renduinix software, when I'm talking about prototypes or what I'm working on or showing stuff and pictures. If you want to stay up to date, this is the place to be for stuff like that. I'm always updating. But yeah, John over here actually has his own little blog, and he figured some stuff out about the bit reading. So I was helping him out because he's got a 2.5 liter, and, you know, he's one of them smart guys where it's like, you know, I could, you know, see what other people do, or I could try to do it myself. So what he did, this is his blog, by the way, is I helped him with the early math, and then he actually figured out the bit stuff, which is cool. So if you notice over here, you know, bit 1 and bit 3 change for that. And when he said that, it just clicked. I'm like, wow, that makes so much sense. Because there's all those different, you know, bytes in there, and inside each byte is 8 different things, so you could flip them on or off for all them signals. Same for like AC and the throttle switch and all that. So yeah, big shout out to John. Thank you so much for figuring that out. That is going to make things so much easier in the future. So yeah, props to you, buddy. Thank you. You know, that's why I keep this open source, because it's really cool to see when the community works on this stuff and everyone helps each other out to figure things out. It's just cool as heck. So yeah, if you want one of these prototypes, let me know. And I'm taking payment now if you like. It's still probably going to be a week or two. I haven't been able to road test this because the Jeep's down. It needs a lot of work. It needs a radiator and exhaust and all kinds of crap. But once I test these and find out that they work and the code seems like it's good, I'll start sending these out. So you can let me know what kind of color screen you want and payment and all that. So message me on Facebook or YouTube or Instagram or email or however the heck you want to get to me. If you want to try one of these prototypes out. It's going to be a couple months for these guys, as I still have a lot of hardware to do and some software to do and stuff like that. If you want to see Arduino tutorials, let me know if you're interested in that and what you'd be interested in. If you want to learn about certain aspects or go over details or stuff like that, we can do that. Okay, and you HO guys out there, I know, I still haven't forgotten. So if we come over here in the pile of stuff, see that guy right there? I do have myself an HO ECU. It's been sitting around for a while, but it's going to be a while. As you can see, I have a lot on my plate. A lot. This stuff takes a long time, but the cool thing is this is a universal controller, so you can use this on any vehicle, anything. It doesn't even have to be a Jeep. You know, as long as it's got 12 volts and a fan, you can use this guy. Hell, you could even use it in a computer if you wanted. But, yeah, so this could work for you guys for now if you've been dying for some kind of fancy doodad in your Jeep. But as for making an OBD1 HO scanner, it's still going to be a while, man. Once I get the REM set up, if I get REM V5 set, and I'm really happy with the hardware, and I can keep them in stock, and everything looks good, and I'm pretty happy with the software, because there's not a whole lot left to add on this. Now that I got the fuel tracking and the graphing, those are two major features I wanted to add. There's not a ton left. Next is just going to be major diagnosing. So I want to do a no-start diagnose where it reads all your sensors to tell you why, what looks weird when it doesn't want to start. I also want to fix the check engine light to make it a lot more useful. So we're going to have, it'll actually tell you what's been tripped, so you can actually look back instead of just trying to see real time. Now we're going to save what CEL's tripped over like the last the last 5 engine starts, so you can actually see a check engine light history. That'll be useful. More advanced sensor testing, so we'll actually have sensor tests, like, okay, test TPS, and then it'll show you like a graph and tell you to push it down and do things like that to actually test them in case we have things like that. So a lot more diagnosing features are going to be added into that. But once I get this solid and I'm really happy, and I can just start selling them, then I'll work on HO, because HO is going to take a long time. You know, the Renix stuff, we're coming up on a 1.5 years, and I'm just now starting to feel like I really understand the system. So it's going to take a while to debug everything and figure out how it works and what all that is, because that's a lot more complicated. You have to actually talk to that. Renix is dumb. It just spits everything out at you, and all you got to do is know how to read. With that one, you actually have to ask it questions and ask for information and parse it, and you have to get into communication protocol. It's complicated, so it's gonna be a while. I gotta figure out the new adapter. I gotta figure out how it all works. There's a lot. It's stupid complicated, so it's gonna be a while. I'm sorry. I know I've been telling you guys to wait, but I need to keep my sanity. I'm sorry, but for now I need to focus on the Renix guys. I need to get these out. Once I can keep these products flowing and it's real smooth and simple, then I'll work onto that. So that'll be later for sure. But I haven't forgotten. So anyway, that's all for now from the Nick and Tom Design stuff. So, if you're ever looking for stuff, check the Facebook page, check the Instagram, check the website. I have a website with all kinds of cool stuff, so you can see information on all the products. I've got a blog that I don't really keep up. I really just copy things over from the Facebook page, but there's stuff in there if you want to read through that. We got support for frequently asked questions, fan control, pin support, regulator fixes. We've got downloads for all the software, even some custom stuff in here. So the fan controller, the shifter, product manuals, resources. It's all on here, man. Take a look at the website. There's lots of good stuff in there. So anyway, stay tuned. I've been very, very busy. So, oh man, goodness. Okay. That's all for now. So let me know what you think, because things are getting interesting.